Why are complex numbers so weird? Why do they not seem to fit the pattern of anything that came before them? I believe they stand at a turning point of our reasoning, and maybe they reveal something about what it means to be human. The truth is, one can look at mathematics and think rightfully of it as being such an abstract mess. It is very easy to overlook that it all had to sprout from very tangible things. Everything that comes before C feels so natural. I find it really hard to buy into the idea that mathematics should be the essence of the universe, as if math were to be a piece of fabric and then everything would just be paint laid on top of it. I'd say this science is more like a painter trying to capture what the world presents to him on a canvas. You would never dare to say a painting is essential to the landscape it reminds of, but merely a representation of it. If math really was something so intrinsically connected to the world we live in, wouldn't it be easy to let it hold your hand? After all, it would certainly have to keep the answer to any question it could pose. All you would have to do is scaffold up with its rules and see where it takes you. And yet, instead, our very own science succumbs way more to our own choices than to anything else. Say you, the mathematician, have built your way up to the real numbers and are now trying to find solutions to polynomial equations. Up to this point, you have been able to easily see everything you work on represented in your surroundings. It is only now that issues start to appear when you pose yourself questions such as x squared equals minus 1. Quantities you could until now hold in your hand are no longer sufficient to represent answers to all questions. The reals will definitely not suffice, and you come to the conclusion that you have two choices. 1. You can accept to leave some things undefined. After all, it would not be the first time. Or 2. If you consider it to have any value, you can dig deeper and you can actually build a place where these questions do have answers. You choose the second option and invent the imaginary unit I, such that I squared is equal to minus 1. Right off, this new thing you created cannot really stray away from R. After all, you only invented it to solve an equation of real numbers, and it just so seems that I can never let go of some sort of real companion. You now have this new number axis which is strangely similar to the real one, but on it everything is multiplied by our new invention. You pick a point on the number line and you see what happens when you multiply by I. Once, twice, 3 times and 4 times. And something strange occurs to you. It's quite an interesting cycle. The number disappears from the old real line just as it appears on your new line, and vice versa. It's just like rotating 90 degrees. And you might think to yourself, this is strangely similar to the axis on a Cartesian plane. And it is. It's just that there seems to be a large amount of empty space that you can't get to. Could it be that what you just constructed hides something greater? There is only one way to find out. Get lost even deeper. You go back to quadratic equations and now, suddenly, your new invention can find solutions to all of them. A negative discriminator is no longer a roadblock. Solutions appear stranger, as a mix of a real component and your new I. But it's not only quadratics. Every polynomial equation has solutions in this form. You go back to your old diagram, and you think this might be able to fill in the empty space. Maybe it is not immediately obvious to you how big of a leap you've just made. You could argue all the other times when new numbers, wholes, rationals, reals, were invented, it was just like this. But look at it this way. For all this time, you're captive to the number line, and everything you could do was like adding or removing water from an infinitely large container. Say it could also hold negative amounts. Now, what about I? It is something completely different. You no longer move only on your old axis. You can leave it. You can add to the real component without affecting the complex one, and vice versa. You now have a new degree of freedom. 1 and I are forced to coexist, but they will never mix. They're just like oil and water, and complex numbers are an emulsion. Aristotle said that we cannot think beyond what we have images of, and that was certainly true for the beginning of reason. At some point, though, the images became the very problems we built for ourselves. Although we cannot possibly claim to be free of our worldly roots, we, as humans, can build beyond what we can see. Maybe it is this ability to abstract that makes us what we are.